The binomial probability distribution is used for variables that only have two options, such as yes or no. Other examples might be success and failure. Could do heads and tails, correct, incorrect, works or doesn't work. Those are all kinds of examples that you'll see in these next few videos. So we have to have 4 requirements to use a binomial probability distribution. We have to have a fixed number of trials. Which is n. Each trial has to be independent. Which means any previous trial will not affect the outcome of any future trial. Each trial has 2 possible outcomes. And the examples are listed above, such as success or failure, heads or tails. And the last one is the probabilities for 2 possible outcomes are the same for each trial. So, for example, if I was flipping a coin, the probability of heads would be 0.5 and the probability of tails would be 0.5. That needs to be true for every time I flip the coin. If you're guessing on something and say that the probability of a correct guess is 25% because there's 4 choices, that 25% has to hold up for each trial or each question that you guess the answer to. So, some symbols that we're going to be using in the binomial probability distribution. We have a little p, which also is represented by the probability of S, or probability of success. That's where the S comes from. So you could also, this could also be the probability of yes, probability of it works, probability of guessing correctly. And then Q, or the probability of failure, which is where the F comes from. Could also be the probability of getting no, doesn't work, or guessing incorrectly. Now, since those are our 2 possible outcomes, and there are no other outcomes, they have to add up to 1. So if you're given one of these probabilities, say you're given the probability of success, or P, you can just subtract that from 1 and you'll have the probability of failure, which is Q. So we can rearrange this either way to solve for one that we're missing. Okay. N is our number of trials. And X will be our number of successes out of N trials. X has to be smaller than N. Or it could be the same as N if you get success every single time. So if I was flipping a coin and I flip a coin 6 times, that would be N equals 6 for a number of flips. And say I got heads 4 times, X would be 4. And Px is the probability of getting exactly X number of successes out of N trials. So I have an equation below this that we can use to calculate the binomial probabilities. And you'll see we have probability of x to start out with. So the probability of getting exactly x successes in n trials. So again, if I was flipping coins and I want to know the probability of getting 4 heads out of 6 coin tosses, I'd be calculating the probability of 4. So I'm just going to put that as an example out of here. 4 heads in 6 trials. So I would say the probability of 4 equals, then we put n exclamation point. The exclamation point stands for factorial. And you'll see I have under here, that means you take that number and you multiply it by every number smaller than it all the way down to 1. And I also show you where that is in your calculator. It's under the math menu and probability. So that goes on top. Then we have n, which is 6, minus 4 factorial times x, which is 4 factorial. And then we multiply. So the p in this case, since I'm flipping a coin, it's going to be 50-50 or 0.5. So 0.5 to the x, and x is 4. And since we're using 0.5, p and q are going to be the same because they add up to 1. And that's going to be to the 6 minus 4 n minus x power. Okay. So you can see this would take a little bit of work to get this all into your calculator. So under this equation, I also have the instructions for how to do binomial distribution automatically in your calculator, where all you need to do is put in some values and you'll get the probability. So we're using binomial probability distribution, and you enter n, p, and x with commas in between and hit enter, and that will give you the probability of x successes in n trials. There's a little information here about doing at least. I'll show you that when we get to examples in an upcoming video. Okay, so both of these, the binomial PDF and binomial CDF, are both in the distributions menu. That's where we also were using distributions to do z-scores in an earlier chapter, and we'll be using that again in a later chapter as well. So all in the distributions menu.